Self-hosted, offline, fully privacy-respecting AI. That's something I'm super duper excited about at the moment, and that's the topic for today's video. Self-hosted local AI puts you in control of your own data, and once you've purchased the hardware to run it, that's it. No ongoing subscriptions. So if you've been concerned about sending your sensitive data to third-party AI services, or perhaps you're just curious about running powerful AI locally, this is the video for you. Today, we're going to be covering how to set up Proxmox as our virtualization platform and configure PCIe Passthrough to directly connect our Nvidia A4000 GPU to our AI-powered virtual machine. This GPU is a powerhouse when it comes to self-hosted AI workloads. It's relatively affordable, it has a small power budget of only 140 watts or so, and it's got 16 gigabytes of VRAM. That's more than my 3080 in my gaming rig next door. And you can see it's tiny. It only takes up a single slot, as well as only requiring one single 6-pin power connector. No 12-volt melting cables here. So to run these models, we're going to use the fantastic software called Ollama. This tool gets you up and running with LLMs locally really quickly and easily. And that means that nothing ever leaves your devices. You can run whatever models you want on these devices by going to Hugging Face or Ollama's library of available models. And after I've shown you how to set all of that up, we're going to get involved with a little bit of NixOS. That's right, folks. The day where the Tailscale channel talks about NixOS is finally here. Because that's what's running all of this stuff under the hood. We're going to create a NixOS virtual machine, sort of a one-click basecamp, like an AI basecamp. A simple virtual machine has everything installed, including the Nvidia drivers, Docker, Tailscale, and everything else I could think of that you might need to get started with local LLMs in one place for today's video. Then towards the end of the video, I'm going to show you a piece of software called OpenWebUI. This is essentially a front end that kind of mimics a little bit like what ChatGPT and Claude and all those other guys are doing by presenting a web app, like a web front end for Ollama, which lets you manage the models and share it with friends and family. So by the end of this video, you'll have a completely private AI setup that keeps all of your data on hardware that you own and control. You'll be able to run these models locally on an Nvidia graphics card of your choice and make those models accessible securely from any of your devices anywhere on your tailnet. So that means if you have a random home assistant that you want to connect to an LLM and have it kind of think about the intents and stuff as Home Assistant moves into the realm of voice control, you can then use this over your tailnet to maybe a friend's GPU, like for a few of you clubbed together, buy a GPU and share it between a few of you over a Tailscale. You could absolutely do that by watching today's video. All right, so if you've been around this channel for a while, you'll know that I have a couple of pillars in my home lab that are non-negotiable, shall we say. Proxmox is one of them. This is my virtual machine platform of choice in my home lab. The second one is Docker. Wherever possible, I will try and run applications inside of a container just because I prefer I suppose the segmentation that it gives me. It lets me separate things and, you know, slice up the sausage in a certain way. And it draws a nice boundary around the application and its dependencies and its runtime versus persistent data. The third one, which I actually haven't covered much on this channel yet, is NixOS. And NixOS is a declarative version of Linux that is essentially just a whole bunch of symlinks. It builds a whole symlink tree all the way from the very top of the root file system down to every single binary and config file that gets installed into the NixOS system. So that's what we're going to do today. We are going to deploy a NixOS VM on top of Proxmox that has access to the underlying graphics card, an Nvidia A4000 in this case, using a technology called PCIe Passthrough. We'll come on to that throughout the video, don't worry. Essentially, though, what it means is that the virtual machine has direct access to the graphics card in order to run the LLMs with as little overhead as possible inside the virtual machine. It's a pretty cool technology if you've never seen it before. I think maybe 10 years ago, Wendell did a video about running Grand Theft Auto 5 on Arch Linux using the exact same technology with a Windows virtual machine, except we're going to be doing it on NixOS instead. So That's what we're going to do today. Deploy a NixOS VM on top of Proxmox with all of the Nvidia drivers taken care of. And then for fun, we're going to put Ollama on top of that and use an app called OpenWebUI to kind of act as the front end to Ollama, so we can actually access these models wherever we would like on our tailnet using the Tailscale serve command. As always, I will put chapter markers down below so you can skip around and find the bit of the video that you need. Also, in the description down below, there'll be a link to all of the source code and kind of snippets of Nix configs and Ansible stuff that we're going to run throughout this video. So if you need any of the resources that are on the screen, they will all be linked in the description down below to the Tailscale dev GitHub repository, where all of this stuff for all of my videos always lives. So the first step we're going to need to do is download the NixOS ISO to our Proxmox shared storage. We can do that by going to nixos.org and scrolling down beyond the Nix package manager section to NixOS, the Linux distribution. Now I'm going to use the minimal ISO image here, and by going to my download section here, I'm going to copy the link by going into the full download history page, copying the link here by clicking on this icon, then going back to my Proxmox cluster, clicking on whatever storage I want to use for ISOs, and just click download from URL. When you do that, you'll put the URL of the ISO in, and Proxmox will go and figure out where the actual ISO lives. Then you can click on download, and it will go ahead and download the 1.1 gigabytes that forms the minimal NixOS ISO. When that download is complete, you'll end up with something that looks a little bit like this: latest NixOS minimal x86-64 linux.iso. The next step is to create a virtual machine. So in this case, I'm just going to put a VM ID of 3710 because it lives on a VLAN in my home lab dedicated to Tailscale demos with a tag 37. So in my head, it makes sense. You call it whatever you want. You call the VM ID whatever you want. I'm just going to call this Nix Llama demo. Again, the name is unimportant. OS, we do need to select the ISO that we just downloaded. So latest NixOS minimal ISO. Now under system, a couple of things that are important we tweak here. In order for PCIe Passthrough to do well, you want to be using a UEFI type BIOS. So OVMF. You want to uncheck pre-enroll keys for Linux. I have run into issues with that in the past. And then we're also going to make sure that we have a QEMU guest agent installed in our Nix config once we've finished. So go ahead and check that box too. Now disks, you must make sure you select virt.io block. Some of the partitioning stuff we're going to do in a minute expects a certain, instead of VDA, it expects dev SDA, or the other way around, I forget which, but just make sure you select virt.io block. That's the most performant one. Select the storage that you use. I have a U.2 NVMe SSD that I put all of my VM disks onto. Works very nicely. And again, I'm just going to put a 100 gig disk and discard because it's an SSD after all. Next, CPU requirements. I am going to put 16 cores because we're going to be taxing this thing quite hard once we put the LLMs onto it later on. Memory, again, if as much as you can throw at this thing, it's not going to hurt. So I'm going to put 32 gigs of memory available to this virtual machine. And then for my case, I'm going to put a VLAN tag of 37. You probably won't have a VLAN tag, but if you do, this is where you configure it. Once that's done, you can click on the button here that says Start After Created, and then click on Finish. Proxmox is going to go ahead and start that virtual machine with the parameters that we just configured. And we can now jump into the console and actually go ahead and install NixOS. So you can see that already we've booted into kind of like the grub menu that lets us select the installer phase. I'm going to click on Install. And once it's booted, we are going to set an SSH password so we can jump out of this kind of VNC type spice session and have something we can copy and paste things back and forward between. So we're going to go through the installation process here. I'm going to set a password just with passwd. This lets me SSH into the virtual machine as soon as possible because I know it's super tiny and you can't see it very clearly. So 10.42.37.103. Okay, and then I need to make sure that my user is NixOS, and then there we go. I'm now SSH'd into that remote system. So I'm going to disconnect seems a bit weird to connect and then immediately disconnect. But now I'm going to use a program called Just. In the root of the Git repository that is, where is it? Over here. There is a Just file, and this Just file basically has a bunch of recipes inside it. One of them is called subupdate, which does a bunch of stuff with submodules, which we'll come on to later on. Another one is install, and then you provide the IP address, and then over SSH, it installs NixOS for you. And then there's a couple of other things that we don't need to worry about right now. So the first thing we're going to do is the install option. So my IP address is 37.103. So I'm going to do just install. Wait. Just before you do just install, please note that this is a destructive operation that will repartition the drives in your system completely. Now, I assumed in this scenario that this is a blank virtual machine and that isn't really going to be much of an issue for you. But please, just in case you're running this on a live system or something a little more, important than just a test virtual machine, please triple check the code is doing what you think it's doing before you run it, because I would hate for you to accidentally delete something just whilst you're supposed to be doing having a little bit of fun with Nix and AI. So just install is a destructive operation. Please triple check it. Okay, back to the video. And then provide the IP address. It's then going to ask me for my SSH password, and it's going to go to town. It's going to start provisioning the disk layout using a program called Disco. And you can see as all this stuff scrolls by, it's bringing in a bunch of packages to do things with Git, and then all of the installation dependencies for things like the Nvidia drivers that we're going to need, and some of the other tooling too. But what's happening right now is it's actually partitioning the disk. So dev/VDA is the name of the disk that's actually available to the virtual machine. And it's partitioned that entire disk for us in that time, because we've declaratively declared that that's what we want the disk layout to look like in this situation. You should probably bear in mind that if you run this script without changing things, it's a destructive script. So it's going to repartition the device that it finds under /dev VDA or SDA, I forget. It's in the code. So yeah, just, dragons are here and available for purchase if you go this route. But really what I'm here to show you today is just sort of whet your appetite, really, that you can install a declarative Linux system to run and act as the base, like your AI basecamp, where you run all these models from. There will be some modifications to this required if you want to put it onto your own infrastructure, of course. But for the purposes of this demo, you can see that things are just humming along just fine. And voila, the installation is complete. That took about 3 or 4 minutes on my internet connection. Obviously, it's downloading a bunch of packages like Nvidia drivers, all of the Linux system deboot, like all of that stuff. It might take 10, 15 minutes, depending on how many CPUs you allocate to this virtual machine, how much RAM you've got, what your internet speed is, that kind of thing. Before we reboot this system, though, we do need to do one more thing, and that is set a root password on the freshly installed NixOS system. So if we do NixOS-enter --root/mount, we are now pretending that we are in the freshly installed system and we've booted properly. So we can set a root password here. That's just what I'm going to do. And now we can reboot this virtual machine. I'm going to type exit here to exit the chroot kind of entered environment that we're in, and then just reboot. And this is going to reboot the installation environment, the ISO environment that we were in. So if I go back now to my Proxmox interface, we can see that we've got Proxmox booting just fine. So one thing I'm going to just change whilst this is booting for the first time is I'm going to change the display driver, because later on when we get to the PCIe Passthrough part, we're going to need to have the GPU in order to get any display output. So I'm just doing that now whilst I remember. And if we go back to console, we can see Nix LLM has now booted. Fantastic. So I set a static IP on this thing of 10.42.37.100. And I'm going to show you that in the Nix config here. So 37.100. And you will want to go in and modify under Nix LLM and default.nix you want to go in and modify this networking configuration before you install it. And also, by the way, make sure that your interface matches. In a Proxmox environment, it should be a static thing, depending on the, I suppose, the drivers that you pick. So if it's a VirtIO driver or a E1000, whatever, this interface name might change. So a couple of things to be aware of here, but I like static IP addresses. They just make things easier sometimes, particularly when working with VLANs and trying to do stuff for these demos as I'm spinning things up and all sorts of craziness over here. Okay, so we're now going to SSH as root into our target system, and we are now inside the NixOS VM. Fantastic. So we want to just very quickly check we've got all the Nvidia tooling in here. Okay, we don't have a GPU enabled. So that's probably a good moment to switch to the PCIe Passthrough part of this video, where we actually give this virtual machine access to the underlying Nvidia A4000 GPU in the physical host system. Now, I'm kind of in two minds as to how to proceed with this next section. PCIe Passthrough is a topic that could, by rights, be its own tutorial series. However, this is a Tailscale channel, and we like to talk about networking and all that kind of stuff instead of like physical hardware. There are so many gotchas when it comes to PCIe Passthrough. You need to have the exact correct GPU revision and sometimes even the correct BIOS on the GPU. You also need to make sure the motherboard has the exact correct BIOS and the CPU can support it as well. So I'm going to put some links in the description to videos about PCIe Passthrough, the Proxmox documentation about PCIe Passthrough, and also the video that I made about the AMD EPYC server that I'm running this on. There's a video in the description that talks more about that. Right, let's undigress and get back to the topic at hand of actually attaching the graphics card. I'm going to assume at this point that you have a system which is capable of PCIe Passthrough. If you want to know more about Passthrough, by the way, just leave a comment down below, and if there's enough people, I'll make a video for this channel specifically about Passthrough. That's my promise to you, okay? So let's go over to Proxmox now and look at the hardware tab for the virtual machine. You can see the change I made to my GPU, my display here. But what we actually need to do is make sure that we've got a graphics card in its own IOMMU group that we can pass through to the virtual machine. So to add that graphics card to the virtual machine, I want to go over to Hardware and then click on Add, and then PCIe Device. Under Raw, I want to select, well, I want to sort by IOMMU groups, and you can see here that I've got an Nvidia graphics card in group 13, lucky for some, I suppose, at PCIe ID 81. So I'm going to click on All Functions, so this passes through not only the video side of the card, but also the audio side of the card as well. I'm not actually going to be using the audio side, but I just, out of habit, I think, click the All Functions button and then click on Add. And it's as simple as that. You know, once you've got everything configured on the server side, the physical host side, I mean, there are some kernel modules you might need to pay attention to, but again, that's all in the Proxmox documentation. And it really is quite a straightforward process these days, assuming you have compatible hardware. Caveat, huge, massive, city-sized caveat hanging over my head right now. All right, so let's jump to the console and just see if the system is booting. Looks like it is. And once it's booted, we're going to SSH back into it and do NVIDIA SMI again and just see if our graphics card is detected. Voila! We have an NVIDIA RTX A4000 GPU running in power state 8 at 54 degrees Celsius, and the fan speed is 41, and there we go, 16 gigs of VRAM, so you can load some pretty tasty models inside this thing. So what do we want to do next? We've got our virtual machine created, it's running NixOS, praise be to Nix, and we've proven that the graphics card is now available to the host, the VM, sorry, using NVIDIA SMI. It's probably time we spun up Ollama, right? So we're going to do that using my other favorite homelab pillar, Docker. So Docker's enabled on the remote system. Good, check. How do we now tell Docker to run Ollama? Well, I like to use Ansible to do that. You can absolutely just copy and paste Docker Compose YAML files around, but I use a bit of a a labor of love of mine of an Ansible playbook that I wrote years ago now that essentially ingests a YAML file here. You can see it's just bringing in Ollama and OpenWebUI. There's nothing special, particularly in this YAML file to Ansible or to Ollama or to Nix or anything. So all Ansible's going to do is basically copy this YAML file from my laptop here to the remote Nix host. And the reason that that's useful is because when you start wanting to put things like secrets, maybe like Tailscale auth keys perhaps, into these files, you don't want to commit those to source control unencrypted, right? So you could actually have here, a variable of ts auth key secret, whatever, and then have that encrypted by Ansible Vault or Git Crypt or any of the other plethora of ways to automate encryption of secrets. Now, I'm not going to get into that today again because of the scope of this video is already plenty big enough with things like PCIe Passthrough and LLMs and yada, yada, yada. Likewise, I'm not going to worry too much about explaining the intricacies of how this Ansible playbook works under the hood. But what I am going to show you is that by looking at the hosts file here, you can see that I've got the host name of Nix LLM. That presupposes that this host is on my tailnet, which it currently isn't. Tailscale's installed, but it's not actually configured. So just for the sake of simplicity and, not having to worry about SSH keys and typing passwords and all that kind of stuff, I'm just going to do tailscale up --SSH. It's now going to go through the standard kind of login prompt procedure that we've all seen on this channel 8 million times, it feels like. And I'm literally just going to add Nix LLM to this tailnet here at tailsandScales@gmail.com. And just like that, my host is now logged in to Tailscale. You can programmatically configure NixOS to log into a tailnet, but again, it's just a question of scope and simplicity of this video. You can configure NixOS to automatically log nodes into your tailnet using an auth key file. So if I just jump over to search.nixos.org, go to NixOS options at the top here and type Tailscale, you can see all of the options that are available to you, as well as some, pretty interesting stuff. You've got some head scale stuff. You've also got an Nginx option here that lets you use Tailscale's authentication as part of your Nginx reverse proxy, like front end. So it will automatically verify that you are you and then log into any service behind Nginx using the auth that's built into Tailscale. Pretty neat. But what I was actually going to get to was this auth key file and auth key parameters right here. So I didn't want to get into encryption of secrets on the Nix side using SOPs or AgeNix or whatever. But if you did, this is where you would do it. You'd configure a services.tailscale.auth key option, and then that would be available under run secrets tailscale key, for example. And so now that my node is logged into Tailscale, when I do an SSH root at 10.42.37.100, I'm still asked for a password. But remember I enabled --SSH. So if I do Nix LLM, that matches the host name on my tailnet, we're actually going to reuse the Tailscale authentication, so I don't need to worry about SSH keys anymore. So we're going to reuse that with Ansible now. So I can use the Nix LLM host name as a target for Ansible, and it will never have to worry about SSH keys. It is glorious as a sysadmin when stuff like that, when that peanut butter and that chocolate meld together and make a delicious Marmite sandwich like that. Oh, beautiful. So Nix LLM and then the Ansible SSH user is root. So if I go back to my and if I type just list, we can see one of the options here is just compose host. So if I do just composed host of Nix-LLM, what this is going to do, it's going to copy across the YAML file that contains my Docker Compose stuff. But there is a little gotcha. I'm using a Git submodule here. So the first time you run this, you'll need to do a just sub update. This is so that it pulls in the dependencies of the Docker Compose generator Ansible role so that it can actually do the copying and pasting effectively of the file across the network. So you'll see the second time I run just compose Nix LLM, it's actually executing a few steps. And now if we log in again through SSH to the remote host, we'll see that we've got a compose.yaml file in here. It's worth noting that the name of the services directory here, Nix LLM, should match the host name that's in your hosts file. So Nix LLM over here, and also the name that you want to target via Tailscale SSH. So just make sure that everything matches up and you should be good to go. So we can see we've now got our very straightforward Docker Compose YAML file, putting all of our app data in /opt. That's a good thing over there. And also making sure that we've got the resources reserved for our Nvidia GPU. So it's time to actually spin up Ollama and OpenWebUI now. Woohoo, this is exciting. So I'm going to do a Docker Compose pull. The Ollama image is typically about 1.5 GB. So it does take a little while to pull down. And then finally, once that's done, that took about 2 minutes on my side. I can do a Docker Compose up -d, and that's going to bring up these containers in the background. If you want to follow their logs, by the way, you do a logs -f, and it's going to show you what OpenWebUI is up to. It's going to show you what Ollama's up to in the background too. But I want to make OpenWebUI available on my tailnet. So in the Compose YAML file, we can see that port 8080 is currently exposed from the container to the host. So if I want to make that available on my tailnet, so any node that is currently logged into my tailnet could currently go to nix-LLM port 8080, and it's going to be an insecure connection and OpenWebUI will work. But I prefer things a little more buttoned up than that. I like a good TLS certificate as much as the next guy. So if I do a Tailscale serve --bg 8080, you can see that now well, first of all, you've got to make sure that TLS is turned on in your Tailscale admin console. So if you go to your DNS settings in your Tailscale admin console, first of all, you've got to make sure you've got a tailnet name here. I've been through this many times on the channel, but just in case you haven't seen it before, there's an option here that lets you rename this kind of slightly ugly placeholder name into something that's a little more human readable. You can re-roll this name a few times until you find something that has both tails and scales. That's the little secret nugget for this video. That's what both halves of the funny name means, a tail and scales. We thought it was funny anyway. So the tailnet name here, Velociraptor-Noodlefish, and then scroll down to the bottom. You're going to want to make sure that Magic DNS and then HTTPS are both switched on. That way, Tailscale Serve will be able to go out to Let's Encrypt and generate a TLS certificate automatically for you. No reverse proxies, no other configuration required. And you can see that I've got a fully qualified domain name of HTTPS NixLLM Velociraptor-Noodlefish proxying localhost port 8080. So it'll take a moment because it's generating the certificate in real time. And sometimes it gets confused. So like if I try and go there right now, it's going to tell me that it's an insecure certificate because of caching. But if I go to incognito mode, you can see that I've got a fully backed TLS certificate right here. Connection is secure. Connection is valid through Let's Encrypt, generated at 12:38. So, time zones. So that's all good to go. And we have a proper implementation now of OpenWebUI. So let's get started with this, shall we? I'm just going to call myself Alex Tailscale. I'm going to do a tailandscales@gmail.com because that's my junk email address that I use in these videos that I never check the inbox for. But you can see that there's a whole bunch of stuff that OpenWebUI is up to. But we want to now configure this to connect to Ollama on the back end. Otherwise, it's not going to be able to run any models for us, and it's going to be pretty useless. So to configure that connection to Ollama, we want to go up to the top right-hand corner, click on Admin Panel, followed by Settings. Next, we want to look for connections, and it's literally going to be looking for Ollama on 11.434. Actually, that should be available. So if we go back to the command line, we can do a docker exec -it OpenWebUI bin bash. We can then do a ping Ollama. Oh, ping's not installed. Is this apt? Yeah, okay. Apt install ping, apt update. It's not just you that runs into these issues. It's me too. And ping is part of course, it's not just the ping package. It's iputils-ping. So now we have ping installed inside the Ollama container. Inside the OpenWebUI container, my mistake, we can actually just ping Ollama across the Docker network locally. So I should be able to manage this Ollama connection already by clicking on the download sort of button over here and manage. I'm going to go over to the Ollama library and find the name of a model that I want to run, DeepSeek R1, for example. I will just do the 1.5B just for the sake of making things faster. So if I do DeepSeek-R1, was it 1.5B, and download that, it's going to now pull down that manifest from Ollama and make it available to us to use within OpenWebUI. Once it's successfully downloaded, you'll get this little toast notification up here in the top corner. I'm going to click on New Chat, and you can see that already it's now selected DeepSeek R1. And I'm going to say, what is Tailscale? I have no idea what this is about to say. But there you go. You can see that Tailscale is also known as a speedway term. No. In computer networking, please. I can't type. But the 1.5 model is a bit dim-witted, but it's pretty fast. Yeah, no. I have no idea. No, that's not what Tailscale is, folks. You can go to tailscale.com to learn more about what Tailscale actually is and not rely on AI hallucinations. That is the downside to using some of these local models sometimes. But let's just see, just for the sake of argument, if I want to manage these models again, if I did like, was it 14B was a bigger one? That context should fit within my VRAM on the A4000. So I'm going to download 14B now. DeepSeek R1 14B, and just download that model. And it's quite a bit bigger, so it's going to take a moment to download. Once it's done, I'll be right back. Right, 14B is now available, and I just want to bring up actually the what I'm going to type watch Nvidia SMI, and I just want to just see, you know, I want to see things in use. All right, so we can see Ollama process is currently in there, and if I just bring this up here and type what is Tailscale, let's see what 14B comes back with. Oh, there you go. 14B isn't a half-wit. It's actually capable of explaining what's going on. And you can see in the background, look, 140 watts, and the performance is pretty good, right? DeepSeek R1 14B is not a small model by any stretch. And of course, you could do Llama 3.3 or Quen or any of these other models that are available. I just thought I'd show you what's going on here. So maybe let's just ask it one more question. How can I bring Tailscale to work? I wonder what it's going to say right here, because the actual answer is to go to tailscale.com/BTW. There's a very generous free tier that we make available for homelab users to get started, 100 devices and 3 users for free. But we have a bunch of other stuff as well, like just-in-time access for enterprise customers to grant abilities to access certain resources for just a short maintenance window, that kind of thing. As I say, you can learn more at tailscale.com/BTW. Now let's see what the AI came up with, shall we? It took 28 seconds to think of that. It's almost as long as my little read was just then, huh? But we can create an account, sign up for free, yeah, blah, blah, blah. Okay. We'll just say tailscale.com/BTW and see what it says. And whilst the AI is thinking on that, I just wanted to say thank you very much for watching right the way until the end of this rather long video about self-hosted AI and the privacy implications and that kind of stuff. There is a bunch of answers coming through here on DeepSeek, talking about zero trust and authentication and all that kind of stuff. Tailscale.com/BTW is the place to go. Now you might be thinking, what else can I do with a self-hosted local AI and Tailscale? Well, you can start sharing this using node sharing built directly into Tailscale for free today. You don't need to sign up for a business account or anything like that. You can literally just go over to your admin console, look for your Nix machine or whatever you called it, click share, and then generate this this invite. And now anybody that has access to Tailscale on their end, you can share this node into their tailnet, and they can access OpenWebUI and by extension access your LLMs and your GPU and all that kind of stuff remotely. So if you have a few friends that might maybe have a Home Assistant deployment that are using some of their new LLM intent stuff to figure out what voice commands are doing, you could share it over Tailscale with them, and everybody could sort of club together and buy a single GPU and share it across half a dozen buddies, right? There's lots of stuff you can do with Tailscale when the internet becomes full of small, trusted local networks. And this is the way the internet should have been, right? Before things got out of hand, this is the way the internet was going. Remember GeoCities and how everybody was having fun there and all that stuff? Well, now we can start sharing GPUs over Tailscale for free to anywhere in the world with no port configurations in firewalls or firewall rules or any of that kind of stuff. It's all built into Tailscale. So thank you very much for watching. I know that was a really weird kind of video for the Tailscale channel, talking about Nix and Proxmox and PCIe Passthrough. Don't forget to check all of the resources down there. There's a lot of stuff gone into this video. And until next time, great big thank you from me for watching. I've been Alex from Tailscale.